Okay, today we're going to do section 11.2, which is simplifying radicals. You may not know what a radical is, but it's that root sign that we often talk about. It could be square root, it could be cubed root, or it could have a 4 or a 5 or any number in this area. But this symbol is called a radical. Let's look at the square root of 24. This is not a perfect square, but we can go ahead and actually simplify it. If you put 24 into your calculator for factorization and get your prime factorization, you'll get 2 times 2 times 2 times 3. Okay, so this is basically what we're saying. The square root of 2 times 2 times 2 times 3. Anything that is that there is 2 of it, because this is just a regular square root, means it's 2 times 2, it can go outside. So if something can pair up, then it can go outside of the symbol. So now this would be written like this, and we have our 2 times 3, which is 6. So we have 2 times the square root of 6. This is not said 2 square root 6. This is said 2 times the square root of 6. Okay, now let's look at the square root of 75. If we break this down into prime factorization, we have the square root of 3 times 5 times 5. We have a pair here. So it can go outside of the square root, so we end up with 5 times the square root of 3. Let's try one more with a cubed root. We have the cubed root of 40. All this cubed root does is say that there has to be 3 now instead of 2 in order for them to get out of the box. So let's look at the prime factorization of 40. It's 2 times 2 times 2 times 5. We have 3 2's, so they can go outside of the box. So now we end up with 2 times the cubed root of 5. Let's look at another one that's a little more difficult. We have the square root of 648. Again, you can put 648 into your calculator and get the prime factorization. The prime factorization of 648 is 2 times 2 times 2 times 3 times 3 times 3 times 3. We have a few different pairs here. We have a pair here, we have a pair here, and a pair here. So each of those can go outside of the radical sign. All of this is multiplication. So what we have left is 2 times a 3 times a 3, and we have the 2 left in the inside times the square root of 2. So when we multiply this, we have 6 times 3, which is 18, times the square root of 2. It's now as simplified as it can get because there is not a perfect square to 2. When you get it down to where the numbers inside the radical sign are prime, then you know you're done. Let's look at one more that's a little trickier. This time we're looking at a cubed root. The cubed root of 14,580. Once again, you can put this into your calculator and you'll get the prime factorization. We end up with 2 times 2 times 3 times 3 times 3 and then a 5 on the end. Okay, so because this is a cubed root, we look for groups of 3. There's a group of 3 that can come out. Here's a group of 3 that can come out. So we have here a 3 and a 3. And we have 2 2's left over and a 5 left over. So we just multiply everything on the outside and everything on the inside. We end up with 9 times the cubed root of 4 times 5 is 20. And you can do this for pretty much any number anytime. The big trick is to always find your prime factorization first. And you can do that on your calculator. I've shown you how. Okay, let's look at another one that might be a little tricky because it involves letters with exponents. Let's look at the square root of 32. X cubed y squared. Okay, so the very first thing we're going to do is we're going to look for our prime factorization. So our prime factorization of 32 is going to be 2 times 2 times 2 times 2 times 2. And then basically whenever you have x to the third, you're saying x times x times x. And when you have y to the second power, you're saying y times y. And again, we're going to look for pairs. So we have a 2, we have 2, we have 2 x's, and we have 2 y's. So all of that can go outside. And we end up here with 2 times 2. Whoops, hold on. Let me erase that. Okay. 2 times 2 times x times y, because we have 2 2's, 2 2's again, 2 x's, and 2 y's. And then inside we have a 2 and an x left over. So now we multiply and we end up with 4xy times 2, the square root of 2x. And this is our final answer. This is as simplified as it can get because we don't know what our letters represent. Now let's look at an easier version of doing this. If we have this 32x cubed y squared, let's think about a number that there is a square root of that can go into, let's think of a perfect square that can go into 32. And I'm thinking of 16. 16 times 2. And then we have our x cubed and our y squared. Our 16 can come out. The square root of 16 is 4. And we still have a 2 left over here. I'm going to underline that so I don't forget it's there. And then we have 3 x's, which 2 of them can come out. When there's 2 of them, we get an x. So we still have 1 x left over. And then we have 2 y's that can come out. And so that's gone. So all we have left over now is 2x. We only have one of the x's left, and we have our 2 left over because that's what I underlined in red.